By first finding the adjoint, determine the inverse of 3, 1, negative 1. Let's copy this down. 3, 1, negative 1, 0, 2, 0, and 1, 1, 1. Okay, well, let's get to work finding the adjoint. How do we do that? We've got to find cofactors. So I usually go one row at a time, and that produces the adjoint one column at the time. Because remember, the 1, 3 cofactor actually gets put in the 3, 1 entry, the adjoint. Okay, and as usual, for the first three, I write things nice, neat. I show my submatrices and show all my calculations, and then successive rows, I show a little less work. Okay, so first row, first column, 2, 0, 1, 1. First row, second column, 0, 0, 1, 1. Okay, well, that determinant's going to be 0 right there. I can tell that. And then finally, eliminate first row, third column, because we want the 1, 3 submatrix here, for the 1, 3 cofactor. So I get 0, 2, 1, 1. Okay, so that'll be negative 1 to the 2 is just a 1. Negative 1 to the negative 1 to the 3 will be minus 1. And minus 1 to the 4 will just be a 1. And then we know how to do 2 by 2 determinants, so 2 minus 0. We get our first cofactor is 2. 0 minus 0, next cofactor is 0. And then 0 times 1 minus 1 times 2. We get negative 2. Great, so that's our first column for the adjoint. Okay. We could even plan ahead here. I know I'm going to use 2 more pages. So we've got the first column here, 2, 0, negative 2. So we'll add to that in a little bit. Okay, so we'll go back here. 3, 1, negative 1, 1, 1, 1, 0, 2, 0. Just double check. Got the right matrix. Yes, we do. Fantastic. All right, next row, 2, 2, 2, 3. So we need these cofactors here. Okay. So you could say negative 1 to the 3, just sort of shortening the work. Negative 1 to the 4, negative 1 to the 5. And then, well, maybe we skip actually writing the submatrices. And we'll just sort of do the determinants as we calculate them. So 1 times 1 minus 1 times negative 1. 3 times 1 minus negative 1. And 3 times 1 minus 1 times 1. All right, so that'll be negative 2. The negative 1 to the 4 doesn't change any of the signs, so we'll get 3 minus negative 1, so 4. And then negative 2, so negative 2, 4, and negative 2. That becomes our next column. Negative 2, 4, negative 2. Great. And onto the last row, which will produce the last column of our adjoint. Again, double check, make sure we're still working with the same matrix. I mean, this would be easier if I had it all on one big scrap piece of paper, but I'm a little limited in what I can work with here. Computer screens are only so big. Okay, so negative 1 to the 4, well, that'll just be a 1. Negative 1 to the 5, that's just a minus 1. And a 1 here. And we'll leave a little space for our determinants. And away we go. So 1 times 0 minus negative 2. 3 times 0 minus 0 times negative 1. And 3 times 2 minus 0 times 1. So we'll get 2, 0, and 6. And that becomes the last column here, 2, 0, 6. So that's the adjoint of our original matrix, which I guess we can add in here. So the adjoint of 3, is it 3, 1, negative 1? Now I've forgotten. 3, 1, negative 1. 0, 2, 0, 1, 1, 1. And you might notice some similarities. There's zeros in almost the same positions, which is kind of cool. Anyway, all right, so we've got the adjoint. There it is. Now we use this as a stepping stone to find the inverse. Remember, the inverse of your matrix, assuming it is an invertible matrix, is 1 over the determinant multiplied by the adjoint. Well, we've got the adjoint. We just need the determinant. How do we do that? Well, you can cofactor expand. Pick any row or column that you want. Okay. Maybe cofactor expand along the third row here. Or, yeah, actually the third row is not bad. Doesn't really matter. So third row of the original matrix. So that's the 3, 1 entry, the 3, 2 entry, and the 3, 3 entry. So we need to match them up with the cofactors we just worked out. 3, 1 cofactor, 3, 2 cofactor, 3, 3 cofactor. But remember, they are in the 1, 3 entry, 2, 3 entry, and 3, 3 entry of the adjoint. Okay, you have to remember that. Otherwise, you're going to be making a mistake. You're going to do this row times this row, and you're not going to get the right determinant. If you're worried about it, do it twice. Okay, with 2 different pairs of rows and columns. If you get the same value, then it's fairly likely you're not messing this up. Okay? That's, only if you got time. So we'll say the determinant of our matrix. And sometimes you can get lucky and they'll just give this to you. But we'll do 1 times 2 plus 1 times 0 plus 6 times... 1 times 6. Don't know what I was thinking there. So 1 times 6. So that's 2 plus 0 plus 6. And so that's 8. And, quickly double check if I do this column here with this row here. 1 times 0 plus 2 times 4 plus 1 times 0 is also 8. So I'm really confident the determinant here is 8. So now, 1 over the determinant times the adjoint. And then we'll be all done. So 1 over 8 times 2, negative 2, 2. 0, 4, 0. Negative 2, negative 2, 6. And so when we go and divide by 8, all of these numbers, all of these entries of the adjoint are even. Kind of interesting. Probably because we have an even row here, but maybe that's even row and then everything else is odds, but that might be the connection. Anyways, so a factor of 2 from 8 will cancel out. We'll just get sort of 1/4, negative 1/4, 1/4, 0, 1/2, 0, negative 1/4, negative 1/4, and 3/4. Okay, lots of fractions there, but only at the very end, which is something I like about this adjoint method. And if you want to, if you've got time, double check that this is the inverse by multiplying it by the original matrix. Okay. Or even, just do a quick test. So third row dotted with first column, second column, and third column will produce the third row, and we should get 0, which we do, 0, and 1. You can just do one quick check like that. Don't necessarily have to do the whole thing unless you really want to make sure, but just a quick spot check, a randomly chosen row or column, make sure it all works out. But there we go. We've got our inverse, and we found it by first using and calculating the adjoint.